Hello and welcome, everyone. I am coming at you live today here with Ellis. We're starting a few minutes late. Forgot to charge my camera battery, and we ran into issues with audio on Linux. Whoever could have possibly imagined that would have been a concern. Alex, how are you doing today?
Doing good, thank you. I'm opening Twitch in Chrome and looking at you from a different webcam now. All very cool. All this stuff you've got hooked up there. Definitely going to have to up my streaming game, I think, after this.
Awesome. Yeah, it's been a process getting everything dialed in, and there's a lot of different inputs and outputs, and I think the hardest thing is getting the latency right. So making sure that you're listening on the Zoom call and not on the Twitch stream, because there's a little bit of a delta between the two.
Yeah, I just nodded on my video, and then I see myself nod a little bit later on Twitch, or put my
Yeah,
hand in the air or something. That's
absolutely.
funny.
So tell us about yourself. This kind of, excuse me, this happened a little last minute. We were DMing on Twitter. Pop suggested that we start talking, and from the looks of things, it looks like you have a quite impressive Raspberry Pi setup behind you. It seems like this was a good idea for us to get together today.
Yeah, absolutely. I've got 28 Raspberry Pis blinking away there. They're not really doing anything other than running Kubernetes. There's no pods right now. And then two 16-port switches underneath that. And downstairs in my lounge, I've got 4 Raspberry Pis net booting, running Kubernetes without any local SD cards. And that's been something that's really fun, also a little bit frustrating. I've been trying to get that working all week, and now it's at a point where I'm going to be close to putting a tutorial out, and other people can go try that out for themselves.
So, question: with the Raspberry Pis that are not using an SD card, do they boot from the USB? Do they use UEFI, or how do you actually get the bootloader up and running?
Yeah, so at the moment, the best you can do on the Raspberry Pi 4 is what you can actually do a full net boot with Pixie. There is no iPixie firmware at the moment, but once you've done your net boot, you can then go over to NFS, have a network file system, or you can do iSCSI, which is a bit nicer, right? Because you get it just looks like you've got a normal hard disk attached to it. But it's a lot more complicated, that approach.
Yeah.
But as you know, or you may know if you've tried it, anybody that's tried it's probably found this, is that you just can't run a container, you can't mount a container file system on an NFS. You can kind of try and hack it, but the overlay file system just doesn't work very well with NFS. So you
Right.
do need something else there. And in this instance, basically, I just plugged in one of these into each Raspberry Pi. And so when it boots up, it formats any any USB drive that's there, and then mounts it. And because I'm using K3s, the only
Right.
folder you need is varlib rancher. And so I just mount a varlib rancher, and everything else is on the network. And that's actually a really nice balance, I think, between the two.
That's lovely. That's really really lovely. In a past life, the first startup I worked at that was acquired by a large tech organization or a company, I was working for a company out of Boulder, Colorado called SolidFire. And we did basically distributed storage on solid state drives, and we had an entire user interface, and we forked the kernel. And the way we approached everything was we basically hacked in at the I/O level, and anything you wrote to disk synthetically behind the scenes at the kernel level would get distributed horizontally. So it was a pretty cool setup, but a lot of my job was messing around with Pixie Boot, Network Boot, and getting things to sort of seamlessly play nice. It was remarkable how much time would go into the success criteria of a DevOps engineer being able to walk into a data center, pull out a drive, stick in a new one, and walk away without having to worry about anything else. But
Yeah,
yeah,
the
interesting, fun
infrastructure
stuff.
is really frustrating and low level. And there's people like Dan, who was one of your colleagues when you came into VMware via Heptio. He's still there, Dan Finneran, and I knew him since we were Docker captains together. He's written a program called Plunder. It's a Golang application, and he wrote it because he thought net booting and everything around it was just too complicated. So he tried to make a Go binary that has literally everything inside of it in one place. And I think that's really fun as well. And he might add Raspberry Pi support at some point. But going back to that complexity, the iSCSI boot option is the best, I think.
Yeah.
But just as I was writing the instructions and running through it, I thought there's no way that people are going to be able to do this. You know, like some hardcore users will manage it, but the majority will really struggle.
Yeah,
And so
iSCSI, it works great when it works, but it's like Kubernetes was 2 years ago. Getting to the place where it works is quite challenging.
Yeah, and you know what? I had one of these Raspberry Pis plugged in earlier, and I got something wrong. And rather than having to mount a disk image, find the offset using fdisk and all of that, I could just go to /nfs, then the serial number, and just hack on the file, which was super easy in comparison to the alternative.
Sure. So I have to ask. I want to see what that cluster looks like. I want to see. I mean, what operating system are you running? How are you running Kubernetes? What are your configuration settings? I have so many questions right now.
I can show you my screen, and I have to make it a bit bigger first so people can read it.
Great. Nice. And while you do that, I'm going to say hello to some of our folks joining from home. It looks like we have MaxGeo92 says hello. Pop, who we were talking with on Twitter, is here. Hey, Pop, good to see you. Large Databank, hi, whoever Large Databank is, and I'm sure we have other people joining as well. Feel free to drop in a message and say hi. We're happy to have you here today. Oh, AJ Kimpara J also says hello.
Nice. Hi, everybody. So I got terminal ready.
Beautiful.
It's going to be this one. So Pop actually has...
Zoom in a little bit, because remember, your screen is in a screen and a screen and a screen.
So I changed my resolution. Hopefully it's a bit better.
Yep, that looks lovely.
What I have here is, this is a mix of things. So start at the beginning. I've got a kube config that's pointing at the master on here. Mm-hmm. And as you can see from the naming, it's running K3S with containerd. And I quite like it because it's a bit more forward thinking. Darren hasn't had to sort of ship with Docker out of the gate. He's gone and said, right, we'll just use containerd. He's put a ingress controller in by default, made some things like Flannel built into it just to make it a lot smaller and use less memory. So really looking at 512 megs of RAM on that master, or they call it a server. And then each worker, I think it's 50 megs of RAM. I mean, it's ridiculously low that it needs to run what you run there compared to kubeadmin.
Lovely. My setup, I went with kubeadmin intentionally because I wanted to get an understanding of what it's going to take to overload a Raspberry Pi or to overload some of these smaller ARM boards, so that when I do my K3S demo, we're going to have a good idea of the delta between the two.
Yeah, I like that too. I mean, I started with kubeadmin as well, and at one point it just completely broke for Raspberry Pi 2, and then it was like very little hope of it ever working again because of certain things. And then there were timeout issues around the initialization and then joining, because the defaults were all for cloud computers that were much more computationally sophisticated. So this has been a breath of fresh air. And then what I used to do is just basically run all of Darren's scripts on it. But now I've got a tool called Ketchup, K3S Up. And what you can do with this is you get the experience that you had in Docker Swarm almost, of install, and then you put in an IP and a username, and it uses SSH to connect with all the options that you've asked for. So it abstracts them away behind these flags, and then that converts it into all the right install settings, and then join. And the join command will then add each node in. So for this big cluster behind me, just really a bit of bash, a loop, install the first one, join all the rest.
Music to my ears. That's what I did on the distro I cut last night. Was I just wrapped up all of the kubeadmin config and all of the kubeadmin flags into just handy bash aliases that are in path, and that basically I discovered that really the only thing you needed was a config file, kubeadmin and a init, and then a join with values from the first init. And as long as you had the config set up, you were able to customize your cluster pretty well. But again, I mean, last night I was running this thing, and my system, I think load average was well above 4 at any given point.
Ouch, that's quite high. I actually have something installed on here. It looks like I've got 20 replicas of this node info function on there. Node info just prints the info about the node, so memory and stuff like that. Figlet is quite fun for demos. I have some other stuff on here as well. But the way that that I've been installing applications is through this arcade application. No, Pop actually has the t-shirt for arcade, which is really cool. And what you can do here is we could set up a Docker registry on this big Raspberry Pi cluster. Sure. And K3s has the local path provisioner in it. So you can even have a persistent volume, the Kubernetes dashboard, metric server. But some of these things don't work on ARM. So like Postgres doesn't, Tecton doesn't. But for each of them, it will actually tell you, like, go away. So if we try something ridiculous like Istio,
you can say that again.
It gets the architecture of the node. And it's like, no, sorry, we know better. And so this is quite a user-friendly tool in that respect. I wonder if we already have the metric server or not. We may have it or we may not, but the metric server is available here that we can add in. And then we can just start doing kubectl top. So lots of fun stuff. Yeah. One thing that I wanted to talk a bit about was how you have a /29 subnet, don't you, for your house? Is that right?
Yes. So I have a /29 and then 2 other publics that are outside of the scope of my /29.
Nice. So how many IPs are in a 29?
8, I believe.
8. Okay. So I had a tweet from someone today, and they said they were just going to open a port on their home ISP because most people get one IP. It might be dynamic, or it might be static or basically static. And they said their ISP won't allow them to open port 80 anymore, and some other ports. And so one of the things that we've got here, actually just have a quick look if I've installed it already, is this inlets operator. Let's have a look. So I don't think it's there. And I can install it and see what the flags are here. What inlets operator will do is effectively, like you've got your /29 or your 2 public IPs, is I can have as many as I can pay for, and they're effectively $5 a month if you use DigitalOcean or around that price on Amazon as well. What happens is the controller sits in your cluster, and if it sees a service of type load balancer, it will basically create a VM in the cloud, run the tunnel server on it, and then you have a pod for the client inside the cluster, and then it basically meshes them together inside, and any traffic that hits that public IP comes to your Kubernetes cluster.
Awesome.
And then we get around those restrictions. So I should be able to do this in one shot and then expose something on that cluster behind me. Let's see, I was wanting to put my token, because you need some sort of cloud token for this. So my DigitalOcean one. And then I'm going to try see if I can put the license in for this. I'll just generate a quick one for myself.
Okay. So yeah, while you're doing this, with my /29, I'm still trying to figure out how I want to do it. I have an edge router coming that should be here, a Ubiquiti edge router that should be here next week.
That's nice.
And I think I'm going to keep a lot of the static off of my local network, but I haven't quite decided yet.
Yeah, so would you have access to BGP to configure that?
I'm
not
smiling
quite
right
that?
now. You can't see me, but I absolutely do. Yeah.
That is a sweet setup. That is really nice.
I'm excited.
So that's a 14-day trial. If anyone screenshots that, they can access this. So Inlets has an open source version, and it does HTTP, HTTPS. But what we really want, if we're going to expose an ingress controller, for instance, is we really want to get TLS termination the whole way down, right inside the cluster. So I can't remember how I actually set this up. So let me have a quick look. The deployment's in kubesystem.
Awesome. Also,
okay, so it's got traffic. And traffic should be, is it configured with a load balancer? It is.
Yes.
K3s has its own little load balancer that is crazy. So it runs something on every node. But on top of that, providing that everything went to plan, we'd get another IP here, which would be the public one. And we can access the cluster through it.
Awesome. We have Craig Tracy, one of my old colleagues from Heptio VMware, in the chat, who is agreeing that Inlets has been a lifesaver for him. Good to see you, Craig. Thanks for joining.
Who was that?
Craig Tracy.
Oh, cool. He's using Inlets?
Let's ask him. He's in the chat. Craig, are you using Inlets right now? And can you share anything about what you have going on? And bear in mind, he's 10 seconds behind us, so he's probably getting that message right now.
So these are the load balancers in the cluster. There's only one, and this is the traffic one. And we can see this is the IP. So if we curl that, it would normally do a page not fan, right? Because it's just an ingress controller. Now there's a nice thing on here that can generate an ingress definition just with a template. So we do arcade install openfaz ingress. It basically says, give me an email. So let's put one in and give me a domain. We'll call it setns.myfaz.club. And that's now going to go
.club. Bravo.
Yeah. We need cert manager for this as well, which also works on Raspberry Pi, which is great. Really happy that James was able to go and do that.
So how are you coming in from WAN? Are you poking a hole in your firewall, or how are you getting into your cluster?
So this is effectively going to create a WebSocket out to a VM in the cloud.
I see. Let
me see if we can get that going again.
So Craig answered.
Cert managers.
Craig said, indeed, I used it to write up local API development, saves me from having to build Docker image and update deployment pod, whatever, to run on the cluster.
That's cool. I think cert manager's still running. So I'll do the canonical example instead, which is just to run an Nginx pod and expose it. So if you see here, run and then expose. So we'll just do that. And then we'll do kubectl get service with a watch, and we will get a new VM will be created for this, and then we'll get the IP here, and people can curl that from the show. We can put the IP in the notes, and if I scale that deployment to 28, we'd probably have one on every one of these Raspberry Pis behind me,
and
people be able to access that.
That's so beautiful. Good job. Well done, sir. Well done.
You know, the reason why the ingress controller is probably better is because then you're only paying for one load balancer IP, just like on a normal Kubernetes in the cloud. You know, you don't necessarily want to expose 100 different microservices with their own IPs. Probably more likely want to do an ingress controller and then get its IP. So
lovely.
That's the one, and that machine is now ready. But it might not be linked up yet. It could take a couple of seconds. And then the connection refuse will go away. You can put this in the chat if I can find it.
And then Mo Zufer just said, will the recording be available? And the answer is yes. All of these recordings persist to YouTube. And I tweet and share a link and push everything to the repository, which all of those links are in the HackMD there.
Yeah, thanks for giving me the time to go through this at my own pace. So that's now working. So we can see the curl is hitting a Raspberry Pi there. And we can probably find out which one. So if we do get deploy, is it deploy or pod? We want pod, I think.
Yeah, you want the pod, and then it'll tell you the node that it's running on.
So the node is 116, and this is starting from basically number 16, and the client for the tunnel is running on 118. And this is the cool thing, because it's acting almost like a router, like your EdgeX router would be, but in software. It's getting the request and then saying, where does this go? And resolving it on the Kubernetes DNS name. So we look at the tunnel.
This is great. This is great.
We'll see, it's saying in Let's Pro. I don't think it's using the Pro. Well, maybe it is. Yeah, maybe it is actually. This is the authentication token. This is the TCP port that we're punching out. So with an ingress controller, there's two, 8443 in the same tunnel. And then somewhere here, in this version, the server says where to put the requests. And in the open source one, it's the opposite way around. You say where to send stuff when you get a message.
I see.
So we could scale that then. Scale is 28. And if we get our pods.
Yeah. And then after this, Alex, I'm going to probably have to cut us off. Loris, the founder of Sysdig, one of the original authors of Wireshark, is going to jump on, and we're going to talk about some stuff he's been doing with ptrace.
Oh, great. Loris.
Yeah. You're welcome to stay and follow along if you would like. So
whilst this is running, have you got time to tell us a bit about your new distribution that you've put together?
Yeah, I'll give you the kind of like the 30-second overview, and then at the end of this, I'm gonna demo it as well.
So
after I talk to Loris, but I'm happy to.
Output is not giving the computer that it's running on. I don't know if you.
Yeah, there you go.
Okay, maybe it was with the watch flag. So now, despite scaling up that deployment, there's still only one service, but we should be able to have a bit more throughput through it now. So if we were to run something like Hey,
you should hping 3 send flood it.
And then it's Z is time, isn't it? If we do 30 seconds with 10 going as hard as they can, we should see. Don't know if we've got that metric server, so we could potentially install that, unless I broke it last time I was here. And then if the metric server does install as we want it to, you can then basically do a top pod or top node in a watch, and you can see it takes a little while to get the metrics in the system.
Sure.
But there we go. So what did we do through a tunnel? We did okay. Right, we could probably get a few more requests out of that if we put it on for a bit longer, a bit more concurrency.
Yeah. So I'm going to jump in really quick, Alex, while you're doing this. One of the things that we're trying to do with Falco is really relevant to what we have going on here, which is providing an easy way to consume metrics from the kernel in a Kubernetes-like experience, like the one you were doing there, such that we could see what's going on in the kernel across a Kubernetes cluster instead of just across a Linux host. And the operating system that I've been working on is catered at bootstrapping this effort of making this entire thing possible in a secure way, which if you think about it, it's pretty challenging, and there's a lot of interesting barriers between what's happening in kernel memory and how do we get that all the way up to a pod running in Kubernetes, and what does those several layers of transactions look like?
Are you going to be looking at having like an immutable operating system, or running stuff in containers on the host, like a CoreOS approach, or what's your kind of...
My gospel that I've been preaching, and the whole purpose of me creating this operating system was so that it would be easy to replicate this for other folks around the world, so we can start to develop this together. The gospel here is using the Falco kernel driver. We would consume metrics out of the kernel, just like the Sysdig CLI tool or Wireshark would do to the network. Bring that up to the user space level in Linux, where the actual user space program would be watched with systemd. The user space program would open a mutually authenticated TLS, or not TLS, but mutually authenticated Unix domain socket. And then there would be a pod in Kubernetes that would mount that socket, just like we would potentially mount the Docker socket, to start read-only consuming metrics from user space. And that's interesting because getting all of that installed with the constraint of only using the Kubernetes API means we effectively have to hack the Kubernetes cluster to install a kernel module on the host below. So a lot of interesting things going on there.
That sounds really cool. I like the way that, so we've got some metrics coming through now as well. We'll be able to pump the CPU on that.
Sure.
I like the way you're talking about that authenticated socket.
Yeah.
How are you looking at doing that?
So right now we have it working with gRPC over the network. And so
gRPC
basically
runs pretty well over Unix sockets.
We're about to find out. And the whole sort of gospel behind what we're doing with Falco is we're starting with a C. Most of Falco is written in C++, and most of the underlying driver code is written in C or C++. So creating those APIs first so that we have at least a structured API we can build to. And we've been looking at using, and I'm speaking on behalf of one of our really smart engineers in Italy named Leonardo Di Donato. He has found a new implementation called FlatBuffer, which is FlatBuffer is to gRPC as K3 is to Kates. It's just it's not protobuf, but it's an implementation that is specifically designed to be lightweight and substantially faster than what you would get with protobuf.
Is this the one that they used in Containerd?
I do not know. It might be.
There was one, I think it was called Tiny RPC, TRPC. But that might be worth having a look at as well.
Yeah.
And I guess you could write your code in Go if that's still what you're into. Because of a gRPC promise of having that interop.
Which was the inspiration for using gRPC in the first place, was so that we could have clients.
Right, yeah, because I haven't done any C++ for a long time. And last time I think was reading some strings off an Arduino for a robot, which is a different conversation altogether.
Yeah. Okay, I'm going to have to cut us off so I can get Loris on here. I would love to keep chatting, and if you want to join in a future episode and talk more, we certainly can.
Yeah, that would be good. All right, thank you.
Yeah, and thanks for joining, everyone. And did you have links in the chat? I know I put a link to your Twitter, but is there anything else you want to encourage folks to check out if they're watching this on YouTube later?
Yeah, so it would be great if you have a look at Inlats, give it a try. If you've got a Raspberry Pi cluster, or maybe you don't have your own /29, there's some links here for you to play around with, including how to get your ingress controller working directly in Kubernetes, 5 years of Raspberry Pi clusters, or if you just want to play around with stuff, Arcade is quite fun for getting basic apps on Kubernetes. And I'm going to be doing a bit more on, I like that shameless plug from Pop there, a bit more on net booting. So if you're interested in not having to have an SD card in and just be able to boot the thing up off the network, follow me on Twitter. There'll be some more coming soon.
Awesome. Well, thank you so much. And I'm sure people will be checking it out. I know I'm certainly going to check it out. Being that I've been in Arch Linux 32-bit ARM v7 land trying to get kernel modules to compile on ARM for the past 3 or 4 days. So what you have here is much more impressive than me trying to compile some C and C++ on a Raspberry Pi.
It can be very tricky and time-consuming, but it's really rewarding, isn't it, when you get to the end and you can show it off.
Yeah, I really like how you've gone like the extra step with the attention to detail, and even having it kind of set up and just so nonchalantly displayed right over your left shoulder there in the background. It really shows dedication, and I think this is the type of work and the level that people expect in modern day enterprise infrastructure, and to see it in your house is really exciting. You've done really well. Very impressed.
Oh, thank you. That's really nice of you. Very kind of you. And it would be great to chat a bit more another time, maybe with Loris himself. I had a nice conversation with Pop. We did the Popcast, talked about some of these projects and where they've come from and what you can use them for. But yeah, it would be good to talk a bit more.
Awesome. Well, all right. Thanks for joining.
I'll drop off now. Go and get my dinner. It's a bit later on in the evening here, but it's been great to be on.
Awesome. Thanks for joining.
All right, bye everybody.
Cheers. And look, there's Loris. I didn't even do it. I'm just standing here drinking Diet Coke. You guys are doing all the work. This is great.
Yes, so I have a little bit of a complaint because you told me that if I was going to join these, you would have had a glass of wine, not Diet Coke, right?
So I ordered a really nice bottle of, it's from Napa Valley. It's Rutherford. I think I got the Cabernet. It's sitting right over there on the counter. While you talk about ptrace, I can go pour a half glass of wine.
Just perfect at 11 a.m., right? Getting
Yeah,
ready
exactly.
for lunch.
It's Friday during the pandemic. What I mean, who even knows what day it is anyway?
Exactly, or what time of the day it is.
Yes. Okay, so Loris, tell us who you are. You're famous. Everybody knows the software you've written, but we want to talk more about you. So introduce yourself.
I don't know about being famous. My name is Loris Degioanni. I am CTO and founder of SysDig. SysDig is my second company. My first company was called Case Technologies and was the business behind an open source network analyzer called Wireshark. I've been involved in open source networking for essentially my whole career, starting in school. And then I started companies around this, and both of my companies have been heavily open source and open core oriented. The first one in networking, and this one in networking and visibility and Kubernetes, and still having a lot of fun being an entrepreneur and a modest coder of open source tools.
Awesome. And so you mentioned you started doing a lot of this in school. So you have your PhD, and that's performance in the kernel.
So actually, I started even before the PhD because WinPickup, the packet capture library for Windows, which was also the first attempt to have essentially a kernel driver for packet capture on the Windows operating system. That was my graduation master's thesis project. And the goal of the project was trying to put a network analyzer on every desk in our lab at the university in Politecnico di Torino when I went to school. And my professor, Silvano Gai, at the time, was a strong believer that the best way to teach computer networks was giving students access to observe, what was going on the networks. But at the point, there was only commercial solutions to do that, and they were very expensive, and we couldn't afford them. So we decided why not starting that, and that evolved into a PhD. In particular, my PhD focused on high-speed packet capture. So a bunch of stuff that you can do in operating system kernels to make acquisition of network traffic extremely efficient, and maybe being able to work on 1 gig, 10 gig, 40 gig networks with pure software or mixed software hardware solutions. And then, after that, I started the company called Case Technologies, and I kept doing packets and high-speed packet capture and network traffic for the following 5 years.
Awesome. So one of the things I added on the show notes today, which we have the HackMD that we've been working out of, and Alex dropped some messages in there as well, is this article that you wrote recently regarding getting Falco up and running with AWS Fargate. So you've explained it to me in the past, but I'm sure our listeners at home would be interested in how in the heck you were able to do deep kernel level inspection running in Fargate, which by design abstracts you away from the kernel. Yeah,
and the trick is a big part of what Falco and other tools that are based on kernel instrumentation, like for example the SysDig open source SysDig do, is instrument essentially the kernel of the operating system at the transition between the kernel and the user, in particular the system call transition, right? Just for a little bit of a background, system calls are a way for applications to require a service from the kernel of the operating system, right? You issue a system call when you open a file or when you close that file. You issue a system call when you read or write on files. Everything related to networking system calls, because all of the sockets user interface, the whole sockets user interface is based on system calls. Connect, accept, bind, send, receive. All of these are system calls. Executing programs, system calls. Forking and executing other processes, these are all system calls. So all of this kind of stuff, essentially like the Falco instrumentation through a kernel module or through an eBPF module, what they do is they sit. There's a couple of places that you can hook in the kernel, but the ones that we do in Falco is called sysenter and sysexit. So there's a trace point in the kernel of the operating system where you can go and instrument that specific point, and when you do that, every single system call goes through that specific point in the kernel. And so when you do that, and you just manage, to analyze the parameters of the system call and stuff like that, you are able to observe all of these operations. And the beautiful thing is that since you're in the kernel of the operating system, it doesn't matter what's running at the user level. It can be running on the host, it can be running in a container, it can be running in a namespace, it can be running. You see everything, because everything needs to go through this multiplexing point for every single system call. Now, doing it from the kernel side is very nice, because you have a very simple, very efficient place to do this instrumentation. At the same time, it's also possible to do the same instrumentation from the other side, from the user level, right? So instead of being in the kernel and waiting for processes to issue system calls and introspect them from inside the kernel, you can do it from the application level. Now, there are 2 or 3 different approaches that you can use when you do that. One of them is the so-called LD preload.
Ah, yes, LD preload.
Yeah, exactly. LD preload is a well-known trick that is used by many security tools, including several commercial tools. So it's a well-known technique that consists essentially in specifying an environment variable before you start the process, and through this environment variable you can tell the system when in taking the C library from the standard directory in the operating system, go to a different directory to get it. You were saying things. Can you hear me, Chris?
Yeah, we're losing you a little bit. Let me try to refresh the Zoom here.
And
sorry about that.
How about now?
I can hear you. Yeah, if you want to keep talking, it seems to be working now.
Yeah, so LD preload allows you essentially to load dynamic libraries for a process from a different directory. So what you can do is you can go and replace essentially the libc, the C library that is used by a specific process. LD preload allows you essentially, since you're replacing the C library that is the medium to issue all of the system calls, allows you essentially to do something very similar to what I was describing in the kernel, with some limitations. The biggest limitation is that you need your target program that you want to instrument to use the C library. And it was typically universally true, so it was not a big problem. But nowadays, there are classes of processes that don't use the C libraries. To give you an example, Go does not use libc. Go,
Yes.
first of all, is completely statically linked, so it doesn't use dynamic library, so this trick just doesn't work. But even Go is just its own implementation, of a standard operating system library, and doesn't really go at all through anything written in C to issue system calls. So the problem with LD preload is that you cannot really instrument anything written in Go, which for us, lovers of cloud native and Kubernetes, is quite a bit of a limitation. The other way you can do this is by using ptrace, the standard vanilla ptrace. Ptrace is a system call in Linux that allows you to, it's essentially the system call that is used by tools like GDB to perform what they do. And with ptrace, you can freeze a target process, you can modify it, you can introspect it. And one thing that you can do with ptrace is you can cause ptrace to generate a trace point or something similar to a trace point every time your target process generates a system call. From inside the trace point, you can essentially do the same kind of instrumentation that I was describing we do now in the kernel. This works very well, very reliably. There are only two problems. One is it's slow. It's extremely slow. The other one is it didn't used to work in Fargate, so it couldn't be used as a user-level replacement for those places where the kernel access is not available, or at least not on Amazon, because Fargate was not offering. Well, the good news is that a couple of weeks ago, Amazon announced their 1.4 platform of Fargate, and ptrace is available there. So that is allowing us to write a ptrace-based instrumentation for Falco that completely mimics what we're doing in the kernel module or in the eBPF module, and offer essentially full Falco functionality on Fargate by essentially using the recently issued ptrace functionality. That is great, and removes one of the issues related with ptrace, which is the lack of availability on Amazon. And hopefully, by the way, this inspires other cloud providers to provide this kind of functionality as well. There's still the other issue, which is ptrace is low. Well, we believe after some experimentation that we have a solution for the two, and that is based on using ptrace to do some dynamic instrumentation of the target processes that are running on these platforms. We're still working on it. So what we're planning to do at this point is start by releasing a vanilla ptrace implementation. Try to do it soon, hopefully in a matter of few weeks. When that is ready, you will be able to run Falco on Fargate. It will be slower than the current kernel level and eBPF instrumentation, but it will be fully functional. So if you are okay with taking some kind of performance hit on Fargate, this will work, and you will be able to use Falco on Fargate. In the meantime, and we'll release this as open source. We're still talking to the Falco team exactly what's the best way for the community to do this.
Yes, we are still talking to the Falco team.
We are still talking, exactly. You know it very well. But it's our intention to really do this in a way that is as community friendly as possible. So that is, the strong intent of me and the other people that have developed this piece of functionality. After we release this fully functional but slightly slower version, then we'll work on a fast one that we expect will work at the same speed as the current kernel instrumentation. And at that point, there will be not only fully functional Falco support for Fargate, but hopefully it will also be at full performance.
This is beautiful. Yeah, this is so beautiful. Obviously I want to try it out. I want to demo it. I want to play with it. And I want to see the code where we're hooking into ptrace and how all of that works. But I think in the future, this would be very, very exciting to be able to run your application in Fargate and then maybe as a sidecar or some other implementation, like running as like a wrapper of the executable, perhaps having Falco also there to check and see what your application is doing, to give you that extra set of concerns of, hey, I am in fact running an HTTP server, but I don't know what's happening to my database that this thing is also hooked up to behind the scenes. But by operating at the kernel level, we can, beyond the shadow of a doubt, understand exactly what's going on in all of our applications we're deploying to Fargate. This seems monumental, game-changing. This is crazy.
And on this feature, we've been working pretty closely with the Fargate engineers, and clearly they are seeing the pain. I mean, it's beautiful to have these like managed containers infrastructures where you don't really need to worry about the host anymore, and you just use any container and any pod when you want them. But the visibility, the introspection needs to get to step up and get up to speed if we really want to effectively take advantage of these technologies, and everybody recognizes that, and hopefully there can be a good partnership between the cloud vendors and open source organizations like the Falco one to really be able to work together. The other thing is, as I was saying, this will be done completely in the open. So I think that for the audience, the best way to stay updated with the progress of these is participating, to the weekly Falco calls, because we'll discuss this there, and we'll make sure that the community is involved and is updated with the latest progress during all of the standard ways that the Falco community uses to stay in touch with each other.
Beautiful. We're excited. We can't wait. And I'll make sure I put a link to the Falco community page, which I owe a PR to the community for, to update our Zoom link. But I'll put a link in the notes as well, and we can talk to folks more about this on the Falco calls and see how we're going to implement this and what that means for Falco and how we can integrate it and make sure that this functionality gets baked into whatever formal release process we decide to do it for. And Loris, it looks like, well, we have one of the other Falco maintainers, Leonardo Di Donato, joined in the chat, and he says hello. And we also had some other commentary. Somebody was wondering Leo was wondering if you're a GDP person or an EDB one, Loris.
Both.
Both.
I love both. I think in the last 6 months I spent a lot of hours on each of these for different reasons, and it's really interesting. Like with GDB in particular, you're never done learning it. That it's so deep as a tool. It's so incredible that I just, every day I still learn something new with it. And EDB is just a phenomenal tool. I love the user interface. I love the user friendliness, and I've spent countless hours on that one as well.
Awesome. That's really rad. So I'm excited to get this up and running, and hopefully, I don't know if next week will be reasonable, but in the future for one of these setns episodes, I would love to have you back on when we can get this thing up and running and actually hack into a container running in Fargate and see what Falco has to say about it.
And do a demo. Yeah, absolutely.
Yep. Cool. And it looks like we have some more commentary in the chat. I see that you made Falco work in ARM, Chris. Wonderful. I got to try it. Leo says that was a joke about the complaints about ptrace being slow, which is true, by the way. Maybe we should clarify that pdig will only be another input mode for Falco. I think the Wednesday calls is the right place to have this conversation. But looking at how we want to bake this into Falco with the inputs that we've been working on for the past few months is going to be critical to the success of getting Falco running in Fargate, alongside a container, next to a container, wrapping your application inside of a container, however we do it. Exciting.
And we're really eager to hear what the community thinks on the best way, to integrate this with Falco. We're at the very, very beginning. Yeah.
Awesome. This is so cool. And honestly, this makes me so happy that, we're able to do this in open source and give this back to the community and work as a community on this. This is really good.
Me too.
I'm happy to be a part of all this, and I'm happy that the CNCF is enabling Falco to work this way and to be able to grow and foster this like they are. So this is great.
Yeah.
Cool. All right, I'm gonna jump into my ARM demo in the last few minutes here and probably go down a rabbit hole of compiling SCAP for ARM. So thanks for joining, Loris. It looks like we just lost you, and I'm gonna take a quick breather. Dito says ARM demo. I'm gonna take a quick breather, and we're gonna get everything set up, and we're gonna look at my ARM demo of running Falco on ARM and what that looks like. So yeah, people in the chat are laughing, and it's always weird when you get back to this point. Here, I'll cut over. Let's see if I can't do this. There we go. I have my little wireless thing here, but it's always weird whenever you go from talking to someone to now I'm effectively talking to myself. And what you can't see is I have a little audience of stuffed animals in front of me, so I'm actually like speaking to an audience here. Let's see if my clicker works. Yep, there we go. Okay, cool. So yeah, thanks Loris, and thanks Alex, and thanks everybody for joining. Those were some great conversations. New technology, some of which is being developed as we speak. The other stuff that Alex was showing, I was aware of it, but I haven't actually seen it in action like that. So that was really exciting to get to see a lot about that. People are talking. You've created your own distro. Is that true? So okay. So let's jump right into it. And I very much appreciate questions right now. It gives me somebody to talk to, and it kind of keeps me on track while I'm demoing this. So let's cut over to my laptop. And to answer your question concretely, have I created my own distro? Well, I guess that depends on what you mean by distro. So I'm using the Linux kernel 4.19.118. I haven't made any changes to the kernel other than adding some extra kernel modules to my libmodules directory. But I have put together a Linux image that comes preloaded with a lot of my own hacking and some really exciting things with the kernel module for Falco and getting Falco and Kubernetes running. I created an image of it, and I pushed it to a registry, which is just a server I have, and I wrote a blog about it, and the source code for what's inside of the image all lives on GitHub. So if that means I created a Linux distro, then yes, I created a Linux distro. And if you want to see more, scroll down to the very bottom here where you see NOVIX, Falco and Kubernetes on ARM. So I've been working on this kind of after hours over the past few days, and I finally was able to get everything working well on ARM. So I wrote a blog about it. So number one, if you want to set this up on your own, please, cool, yeah, they were right, yeah. If you want to set this up on your own, go for it. I would love to get your feedback. And last night on Twitter, I decided I was going to sponsor a Falco hoodie for somebody. And we had somebody get this up and running on their Raspberry Pi in about 15 minutes after I released the blog. So if you're interested, please try it out. Send me a screenshot. We'll try to get you some stickers or some T-shirts or something to show you. You know, we have plenty of Falco stickers, and we have some like this one here I really like because it's got the goose. So we can send some stuff out to you if you get it up and working or if you make a contribution. So I put this on Reddit and on Hacker News because I, for some reason, enjoy the internet giving me a hard time. Dito says, do I deserve some swag? Leo, you've got your very own customized Italian Falco Goose t-shirt. I don't think many people have customized Italian Goose t-shirts. But yeah, we'll get you some swag, of course. We're always going to get some swag, just as soon as I can jump on a plane and fly over to Italy. Dito says he wants Falco pizza. Okay, so if you come to the blog, this kind of explains what it is. And then if you come down here to NOVIX, you can see there's a GitHub repo. And you can come to the GitHub repo. And I wrote all of this on the command line. It's not Markdown. All of this was done via SSH, and I just pushed it up from my Raspberry Pi. I got an Ansible pizza once. Falco got a step up. I should totally order a pizza for my live streams next time. So anyway, if you go to the GitHub repo, you can see we have a few things here. I have my git config. Please change this if you use it. Don't commit to GitHub with my email address, but I kept it there because I'm lazy and I switch Raspberry Pis often, and I wanted to commit from different Raspberry Pis as I was testing this out on different architecture. So there's a bashrc, bash profile. It's got some aliases in it. We have a Kubernetes directory, which in here, it's just some documentation and the kubeconfig master YAML file for kubeconfig to set up your Kubernetes cluster. You can come in here. If you want to make a release of NOVIX, I have a bash script that just does its best to kind of clean up the image before it shuts itself down. Dito says, "Oh, Chris, using ESLint commit convention, the world is ending." Yes, Leo, you got me using a Git convention. Look at that. Aren't you so proud of me right now? No more of my commits like this one. Please don't steal my commits. So I have the Falco kernel module that I built. I pushed it up here just to have an object that people could use. But I also have a Git submodule of Falco, and I pushed this branch up last night. So there's two. There's Falco ARM support, which this is the PR that I opened up to Falco. Let's see here. And this has documentation on how to actually do a lot of what I'm doing. Oh, we lost video somehow. Let me go flip my batteries out. My battery just died. So give me a few seconds and I'll be back with video. And we're back. Okay, so everybody should be able to see and hear me again. Spencer hacked Twitch. Okay, so awesome. Yep, looks like folks can see and hear me. So here's just documentation on what I had to do and how I did it. I wrote this, which this is just really doesn't have anything to do with ARM as much as it has to do with me tinkering with different flags and just wanting them all in one place. So don't merge this. It looks like we have some commentary. Yeah, I would say don't merge this yet. I'm going to clean this up. And I have a second branch that does not have a PR associated with it, which is this one. And this is the one that we actually have on my Raspberry Pi right now. And this one is interesting because there's a few things that needed to happen in order to get this to compile. We needed some changes from the upstream master, but we also needed a stable version for the kernel module as well. So this is a hybrid branch between 0.22.1 and the LPR changes that Lorenzo did to get Falco compiling. So with both of those, we are now able to build both the kernel module and Falco, and you can just use this branch if you want to do it yourself. So without further ado, let's look at my Raspberry Pi. So here we are on my laptop on my network. So you can see right here, this laptop that I am on is, let's see if I can zoom in a little bit. There we go. 10.0.0.41. It's a /24 subnet here on my local network. And I use Ubiquity, which I'm going to show this off really quick. Please don't steal my IPs. I'll do my best to keep everything nice and hidden, but I do have a security gateway up and running. But you can see my network is starting out as right now. And if we come to devices, you can see these are the devices I have online. And we'll go to clients, and we want to see wired. Oh, is my Raspberry Pi not online? let's see. I might have to walk in the other room and make sure this thing is even up and running. Oh, no, it is. Okay. So yeah, I don't know why it's not showing up here. This dashboard isn't the best. But if I nmap.44, which this is just a DHCP address, you can see it's port 22, which is open and listening right now. So if we uname here, you can see I'm running Manjaro on an older version of 419 1.113, and I'm running x86-64, which very normal laptop here. So now let's SSH into NOVIX here. And there we go, everyone. Welcome to my Arch Linux distribution that I have been working on. So the first thing you want to do is, let's see what we have going on here. So Slamp gave me a monkey face. So you can see here, we're running the latest version 1.18. This was cut a few days ago. And we're on ARM v7L GNU Linux, and it's called NOVIX here. And another thing that I want to show you is this command, lscpu. You can actually see the type of architecture, and even more so, you can see the chip that we're using here. So I did some research. I pulled up the GCC recommendations for compiling on Cortex-A72. I learned way more about the -m flag that I want to talk to folks about, and a lot of those build flags I've baked into this branch that we're on here. So let's talk about compiling Falco. So we want to go to the Falco directory. Well, actually, first, let's go here. So if you notice, README, Ben, common, Falco, Kubernetes, and release. If we go back to GitHub, where was it? Here. This is just effectively the home directory, which is, oh, not this, but let's go to NOVIX. This is effectively my home directory, which is the same thing that we see here. Right? Bash history, bash profile, but a lot of these are in the git ignore. If you look in the git ignore, you can see we're ignoring a lot of this stuff, some of which I forcefully added, but that's basically what we have going on here. So anyway, if you look in Ben, you can see I have a lot of these NOVIX commands. So if you want to see the commands that I've baked into this image, all you have to do is type NOVIX and then tab hint, and you can see all the fun things that there are to play with right now. Like right now, for instance, we have Falco logs. So you can do Falco logs. It's going to yell at you and say, run this as root. And you can see we're now tailing the Falco logs. And we'll get more into these commands in a little bit, but let's look at building Falco and talk a little bit about what I had to do. So change directory into Falco, git branch. You can see we're on the Falco on ARM branch, and git status. And you can see the only thing that's changing is I was doing some git config stuff when I was cutting the release last night. So no other files have been changed. So you go into build, and this directory usually does not exist in Falco. The PR I opened up for ARM adds this directory and then creates this shell script in here called init.sh, which is effectively how I was able to pass in flags as I was hacking on Falco. So what I did is I went into init.sh and I defined a few flags here. This one is important. Release for the build type. We want warnings as errors turned off. We want to still basically keep compiling if we get a warning, which we get a lot of. So we definitely don't want to break the build if we get a warning. We have the Falco directory, which is etc Falco, and build bundled dependencies is set to off. This is important. Okay, so let's close this. And then basically you would just run init sh. It's going to set up your build directory for you, make sure you have everything ready to go, build files, and then after you do that, if you list what would have been a directory with only this file, should now look something like this. And you have everything you need to start compiling Falco. You can see we have menu dependencies. Luajit which was a fun one. I had to download a beta version of Luajit to get this to work on ARMv7. There's a handful of other ones. JQ we had fun with the other day on the Falco community call. But yeah, we've got everything working and dialed in nicely. So what we want to do is we first want to build the Falco kernel driver, or the kernel module, if you will. So to do that, we are going to make driver. And it's compiling. And this is usually pretty quick on a Raspberry Pi. The kernel module is not very big, and we can usually make it, probably 15 or 20 seconds. You can see here we're getting those warnings we talked about, so we want to just keep moving, and there you have it. Bob's your uncle. We were able to compile the kernel driver on ARM, which this is kind of anticlimactic because getting to this was like days and me staying up till 2 a.m. every night, screaming at my computer and hacking and dealing with dependencies and C++ and like having anxiety attacks as I'm watching the code compile, just wondering if it's going to get a little bit further than it did the time before. But it works now, and you're welcome. And you can now build the kernel module on ARM. And if you look in, driver, you can see here we now have the Falco probe.ko that we have compiled. So what I did on the image is I set this up to be automatically loaded at startup. So if you list mod and you grep for Falco, you can see the Falco probe is already loaded. It's not using DKMS. What we did is we actually came into this modules load.d directory, and you can see here I have falcoconf, which just has the string Falco probe in it. And how your system knows to look for probes is if you go, for modules, if you go into lib modules, the name of the kernel headers that you're using. So the kernel headers are another story. Getting these kernel headers right was a pain in the butt. But I found that there's a package for Raspberry Pi 4 that had the ARMv7 headers. And if you're running ARMv6, you want to get a different set of kernel headers. That's all documented in that GitHub pull request that I linked earlier. But this is very important if you want to get Falco compiling on different architectures to make sure you have the correct driver kernel headers installed in your system. So here we have 419.118 Arch. So we can validate that this is actually correct because we're running this kernel version as well. Hey, Duffy, good to see you. And that's not necessarily enough to let you know that the kernel headers are going to match the actual architecture you're running on. You could still get kernel headers for a different architecture that match the same kernel version you're using. And it might compile some, but not all the way, which is the case I was in a few days ago when I was downloading both the Arch Linux, the Raspberry Pi, and then I finally discovered there's a third set of headers called the Raspberry Pi 4 headers, which was built specifically for ARMv7. So getting kernel headers right is a big concern here. But these are already baked into the image. So if you just check out the image, you'll get these. And as I release more of these, I'll make it a point to keep this support of always having the headers up to speed and ready to work. So if you come into this directory, Linux parlance dictates that within the kernel directory in here, there's a folder called drivers. So if you go into drivers, you'll see some very familiar subsystem-like directories here in the drivers area. Common ones, we have block devices, Bluetooth, good old CD-ROM, GPU for those of us into artificial intelligence, net, mux, power, PPM. There's a lot of these, SCSI for network file systems, video, etc. So I created a directory in here called Falco. And I actually discovered you can make whatever directory you want. I don't know if this is good practice or not, but you totally could, and then your system will automatically pick up all of the kernel modules inside of that directory in here. So I just created one called Falco. So if we go into Falco, all I did was I copied Falco, build, driver, Falco probe. So this is the one we just compiled to right here. We'll run that as sudo, and we can now mod info this. and you can see we have some information about it and what it's called. This is the string that we're mostly looking for here, called the Falco probe. So again, if we cat etc modules module load falco.conf, that name matches this name. So then I can just do a dep mod. We'll do verbose all, and it will load all of the modules I have configured. Run that as sudo, of course. And you can see everything was loaded. And if we list mod grep falco, you can see it's there. And in fact, we can even repeat the exercise. Remove mod falco probe. Oh, it's in use because Falco's running. Okay. Well, I'm not going to stop Falco for this, but you can see it's actually running here. Actually, you know what? Yeah, let's stop it. Sudo bash. And do we have a stop command? We have Falco restart and Falco reload, but I probably should write a Falco stop, which basically would just do a systemctl stop Falco. Let's see if it's running. psox grep falco. Okay, it's not running. So now we can remove mod falco probe, list mod pipe to grep falco. Nothing's loaded. Dep mod verbose all, and let's list mod. Oh, it's not there. Let's try this. Reboot now. Okay, so restarting my my Raspberry Pi, which this thing fires up pretty quickly, which is quite exciting. So we'll just SSH back into NOVIX. Hopefully this will get back online. I don't know why that dep mod didn't work. I guess there's another exercise I could do here, which instead of doing a dep mod from any directory on the file system, I could have just done an ins mod and then the name, and then it would automatically, the Linux operating system would know to look in that directory we were just exploring for a probe with that name. So you don't actually have to load it from the file system. You can just load it by name at any point. And so that's how we were able to load it. And then, okay, so we're back on our system now. And by having it in that modules.d directory, that tells Linux to load that every time at startup. So list mod pipe to grep falco, and there it is, our newly compiled Falco mod loaded without having to do an ins mod. So we can repeat this exercise. We can't remove it because it's running. Systemctl status Falco. You can see Falco is running. So yeah, so your system rebooted. The first thing it did is it loaded the module, it restarted Falco, and now Falco is running. And we don't even have Kubernetes up and running yet. This is just running at the Linux level, which Falco should be running at the operating level in my mind. If you look at a lot of different components in the Kubernetes stack, a lot of things don't run on Kubernetes, like CNI, the container runtime, Falco, the kubelet. I mean, there's a lot of different things that make Kubernetes Kubernetes and that you depend on in Kubernetes that don't run as a pod, that don't run as a deployment, as a daemon set. These are parts of your Linux system that you use with Kubernetes, which is what I think Falco should be doing. And then we should just have a thin layer on top of Falco that's basically read-only, and it can be managed in Kubernetes, and then we can take events and proxy those off as we will. So, Spencer says, is Falco probe a kernel module or an eBPF probe? Okay, so Spencer, let's check this out. So let's go into Falco, and actually, you know what? Screw it. It's Friday. We're gonna do this. We're gonna do it live. We'll try to compile the BPF probe. But to answer your question, it's the kernel module, not the BPF probe. So to build the BPF probe, or to try to, we'll see what happens. I have a feeling it might work, it might not work. But go into build, emacsr init.sh, which, don't worry everyone, NOVIX comes pre-installed with the latest version of Emacs, so don't worry about that. Granted, it does create another gigabyte of storage when it comes to downloading the operating system image, but you don't have to worry about installing Emacs after you get it up and running. So I know a lot of folks at home were worried about that, but that's not the case. So Yes, NOVIX says the .ko is kind of what gives it away, the fact that it's a kernel module. KO, of course, standing for kernel object, which means it's an object that you would load into the kernel at runtime. Whereas a BPF probe is .o for just object. It's an ELF binary. So anyway, there's a flag here in the shell script I wrote called BPF. And we turn this to on. Pacman minus M, sorry, look at this. Pack R minus F, minus S vim. Oh, I can't perform it as root. But I don't even think, is there VI on the system? There's VI, there's no vim. Yes! No vim on my my Linux distro. It's my distro, so you can't take that away from me. Okay, so let's run our init. I might have already did this, but I forgot. And it's configuring. And now if we cat out our makefile, pipe to grep BPF, you can see we now have a target for BPF. Whereas before I flipped that flag and ran the init file, we would not have had this target. So I can try to make BPF and we could see what happens. I'm kind of nervous, but we'll see how this goes. I might have to go get that wine from over there that Loris was talking about. Yeah, we have a lot of errors here. So this is what I've been working on. This is the more realistic view of what I've been doing for the past couple of days. Dito says hardly builds. Too many errors stopping now. What are these errors? No member named di instruct. Whatever this library is, it looks like where you're using. Plumbing helpers, no member named org ax. Dum. Yep, it looks like it's just more dependency management and more fun there. No need to build this just for me. I was just wondering which one you used. I was kind of, Spencer, honestly, I was just kind of curious. I haven't tried it yet. So anyway, the Falco kernel module loads and boot up. Leo says, yeah, it's missing some fields in the kernel structs for BPF, eBPF precisely. And this is my opportunity here. That's a task for another set. Yes, you read my mind, Leo. I'm going to take this opportunity here to invite Leo and Lore, who I'm sure is at home with his kiddo, little Ricky, Puzzatina, who is one of the BPF knowledge experts and the person who wrote the book on BPF, getting both of them on setns to do kind of a discussion like the one we just had with Loris, and looking at a lot of this would be exciting in the future. Max Geo, you launched it from home NOVIX Falco build. Yes, Max, that is correct. That's where I launched that, and I ran it as root. If you look here. Cool. So anyway, not going to build the BPF probe. Pull request accepted. I might get to it in the future. Max says, thanks. You're welcome. And so now we have the kernel module loaded, and if we list /dev, you can see here, we have 4 cores on my Raspberry Pi 4, and we have a device for each of our cores. Leo says you can also launch CMake commands from the Falco root using another syntax. Yeah, you can also just do like CMake d build BPF, and there's other ways of doing this as well. I just like having everything in this init file, because then it's more like a config file when you look at it, like how all of these flags are defined here, and that way I don't have to remember their names or type them out. I can just have them defined, and if I want to change one, I come in here and change it. E.g. cmake --build target Falco J16. Yeah, well here, if we look at cat proc CPU info, so Leo said J16, which means parallelize on 16 different threads, which would imply that you have 16 cores on your machine. Processor 3, which is 0 index, means I only have 4 cores on my Raspberry Pi. But just because I'm a troll, let's SSH into my server at .100. Ah, yes, there are my cores, and these are hyper-threaded cores, so I have 32 of those. And the new Power Edge, which actually it came in the mail a few hours ago, it's sitting right over there. My new Power Edge just came, and that's going to have even more cores than this. So we can definitely fire up some Falco and some Linux builds quite nicely on a lot of them. Okay, so that's my, well, I call it my server, but I think I'm going to have to start calling it my desktop now, because I actually have a proper server that has yet to be mounted in my rack that I'm going to do after setns and TGIK today. Okay, so let's scroll down and SSH back into NOVIX here. NOVIX at 10.0.0.44. And let's go into build, Falco build, and let's build the Falco user space program now. So make Falco J4, and we're gonna get some warnings. And so this is classic C and C++ programming here. After I got the dependencies up and running, I was getting weird errors. I was getting seg faults at runtime. Like, I was just having a hard time making all of this nice and happy. So I finally boiled it down with the help of one of the sysdig maintainers to a very complicated pull request into the kernel module repo, which if you look here, this is linked in the doc. You can come down here and you can see the kernel driver PR. I just really want to show folks how extremely complicated this PR was, and how days and days of work went into finding this change and to opening up this very highly complex PR against the kernel driver. So if we go in here, we pull it up. It was recently merged, which hooray. And we look at the files that were changed. And I added a capital L to a file here in C groups limit. And that was the magic change, which was basically because we're running on 32-bit, we just had to handle the registry different. Dito is laughing. I am happy because him and Lorenzo basically had the exact same user experience when they were contributing a fix in the Linux kernel recently for BPF that we discovered when we were working on Falco. I'm impressed how many times to find that. That took some time. And originally I had actually done a pound define and added a flag, and it would compile with one value here instead of another if you were running on ARM. And then one of the maintainers suggested just to do a long so that it would support both 32-bit and 64-bit as well. So we got our unsigned long and that did the trick. And so anyway, I love C and C++ because this is just classic. If anybody's worked in large libraries like this, you know that the most complicated changes usually end in the most unimpressive pull requests. Anyway, Falco's still building here on my Raspberry Pi, and we're going to kind of jump over into another terminal here so that folks can see what we have going on while this is building. So this is like the cooking show thing where like you put the turkey in this oven and then you pull the turkey out of that one and hey, it's done. Max says time inversely proportional to lines of code. Yes, absolutely. So let's open up a new terminal here. SSH NOVIX at 10.0.0.44. And here we can start to have, actually let's get two of these going. NOVIX at 10.0.0.44. Bam. Okay, so this one, let's do NOVIX Falco logs as, well, let's zoom in as root. Okay, so clear the screen here, and if we are going to get a seg fault, it's about to happen. So stand by and we'll see how well my code works. So on this one, let's do some of the classic Falco demonstrations. If you've ever seen my KubeCon talks or what I did at FOSDEM, or if you've seen me live with Falco, I have a handful of things I always kind of do to demonstrate how Falco works. So we're going to do a few of those running on ARM and just see what Falco has to say about it. The first one I usually like to do is this. As root. Okay. So beautifully, without seg faulting, Falco on ARM gave us a quite lovely alert here in the systemd journal. This is very important to understand because at the systemd level, at the Linux level, we're triggering alerts that are effectively going to a standard out here, but otherwise would be put into a binary blob, and you could potentially use a tool like journalctl to read that binary blob later in the same way that MySQL stores it, or MongoDB stores their data in binary format as well. So anyway, in the future, this alert would potentially be advertised over a Unix domain socket. And then we would have a pod that would read-only consume this structure out of that socket and then could take action on it. So things that are happening at the Linux level can exist regardless of what's happening with Kubernetes on top of it. So in the case that there's a catastrophic outage or your node breaks or something goes wrong or you're doing a rolling upgrade or somebody hacks into your cluster or there's a CVE or there's a vulnerability or there's one of those Eisen bugs that you can't explain, Falco, meanwhile, underneath everything, silently running in a lightweight systemd process, just keeping an eye on everything for you. Okay, so anyway, let's continue to tail our logs here, and let's do some more hackery here. Holden says, is this running on your Raspberry Pi? Holden, hi, good to see you. And if you look, you name A, it's running on ARM v7. And if I list CPU, Cortex A72 chip, ARM v7, and HTOP, 4 cores, 4 gigabytes of memory. This is in fact running Arch Linux on a Raspberry Pi 32-bit ARM v7. Dito says, "Oh cool, hash crease." Are you talking about my Etsy shadow? Okay, so anyway, let's go back to Falco here. We're using Falco logs, and let's Docker run it -- privileged. Oh, this is gonna be fun. Chris Nova hack. Oh wait, Chris Nova hack bin bash. Sudo chown. I have to change the ownership of my Docker socket because of Arch Linux. NOVIX. I should take a note and open up an issue. I should fix that in the next release of NOVIX. Sudo chown NOVIX var run docker.sock. Run this again. Unable to find Chris Nova hack locally, so it's gonna pull it. Yeah, you can have my Etsy shadow password. I'm just going to delete this container image in a moment I keep calling it a container image because it's in a teeny tiny container, but it's not even a virtual machine. It's a real computer. It's my operating system image and reinstall it as often as I want. So one of my projects for the weekend is going to be just flashing SD cards and getting all of my Raspberry Pis up in line with DHCP and then assign them all static IP addresses on my network. Okay, so the Raspberry Pi is downloading my hack container. Falco hasn't said anything about it yet because we're just downloading from the internet, and the Falco user space binary is still compiling. So I'm drastically overworking my poor Raspberry Pi here. If you look at load average, it's at almost up to it is at 5 now, and you can see my cores are being well exercised, and memory's doing okay. It's not too bad with memory, but yeah. Who thought you could really just max out one of these teeny tiny credit card sized computers? Okay, so let's see what we have going on here. Okay, we got an error because in fact, let's just do Nginx. My hack container is not going to be happy. It does a lot of stuff behind the scenes. It's not going to be happy on ARM. Let's do Nginx. I have a feeling Nginx will be a lot more happy when it comes to running on this architecture. We'll see though. Downloading, extracting. The Falco build is still building, and then we'll get into Kubernetes here in a bit, and then I'm gonna tee off our friends over at VMware for TGIK, which starts in about 20 minutes. Let's see, Duffy, if you're on the line, what's the link for for TGIK. I think there's tgik.io/live. This is the one here. So if you want to see, it's going to be Brian Lyles today. And so he'll get started in about 20 minutes. So we will put a link here. So when I get done, if you want to jump over and keep watching the live streams, please feel free to join Brian over TGIK, which starts in 20 minutes. And you can just go join there. I'll probably join in and troll the chat as per usual. But feel free to check that out as well. And let's go back and see what's going on with ARM here. Hopefully one of the things Brian talks about, I didn't get a chance to go into it. I did put some links here for some good articles that I found this week if folks are just interested in seeing what I've been reading and what is exciting. This Domesticating Kubernetes article is gold. If you love yourself and you love networking and you're a nerd like all of us here on setns and TGIK, stop what you're doing, go read this article. This walks you through how to set up basically the same type of cluster we saw on Alex's Raspberry Pis in detail at your house that mirrors the same type of enterprise level Kubernetes deployment you would see on bare metal. This is a fantastic article. I'm Chris Nova and I approve this message. Okay, so we're at 88% with Falco. So let's go here. Okay, so we're in our container. So now we're going to do the same thing in a container. There's all of my hashes for Leo. And if we journal cuddle Falco, you can see, oh, something happened. Oh, I got my seg fault. Yay! So we have another seg fault we discovered. So I'll get to fix this later on today. Let's actually, you know what we can do to debug this? This is how I've been debugging these seg faults. System cuddle stop Falco. And then I basically just run it in the password for NOVIX is Charlie, my dog who passed away. On that mountain there are his ashes. Anyway, what you can do is you can sudo falco -c etc falco.yaml. So now we have Falco running, so hopefully we'll get an error here. Nope, segmentation fault. I'm wondering if that's because we're using the debug version of Falco, which we should be using the release version being compiled here. And we can check that by going to Falco build, and we can cat init. So yeah, we are building with build type equal to release. So I think what I'm hearing here is I need to cut 1.0.2 of NOVIX with a working version of Falco, and I'll do that later today. The debug flags, those assertion, and that do not pass. Yeah, the assertions, the assert methods or functions look like this in code. Those were where I was seg faulting all day yesterday. So I have a feeling those are what's happening here. Try with a release build. Yep, that's what we have going on, Leo. As soon as this builds, which we're at 100%, and God, yesterday I was getting to 100%, and then it was failing as it was doing the very last few links to get the binary up and running, and I'm just sitting here like, please God, somebody link these objects together so I can have an executable. So hopefully we don't have that problem today. It looks like we're linking the Falco executable, and then we're going to try to rerun all of this, and I'll show you how I installed Falco with systemd, which is different than how it is set up with systemd if you run the Debian or RPM packages from the official Falco releases today. Yay! Falco built! Hooray! Okay, so now what we want to do is let's go up to sudo. So we're going to move the binary we just built, which is user space Falco, and then you see here we have Falco, to user local bin. It should probably be user bin. I put it in user local bin. Sue me. I actually read the man pages. I believe this goes in user local bin. It's my operating system. I can do what I want. Get off my lawn. Okay, so user local bin Falco. Go into here. And now we can systemctl stop Falco just to make sure. And we can now do our Falco -c etc falco.yaml. So remember, we just ran this command and it instantly segfaulted. Nope, core dumped. Segfaulted again. Damn it. So yeah, I don't know. I'll have to keep hacking on this right now, but we can see. You know what? In fact, why did I move this? Let's do this. Systemctl start Falco. Let's check out the Falco logs. NOVIX Falco logs. Yep, core dumped again. And systemd is just going to continue to restart it. Okay. I'll try to look into this and get it working. It was working great yesterday, and it was working quite well a few moments ago. Actually, this might be interesting. It was working until I started this Docker container. So remember, we're in this Nginx container over here in this terminal. I'm wondering... Ha! Ha! Ha ha! Interesting behavior we have found here. I bet this has something to do with the C group limits. Whenever we're running a C group, the kernel module might be overflowing a buffer or something. To fix this, it's not fun. It's not pretty. It's printfs and a lot of patience and some good luck and maybe some red wine or something. Leo says, "Oh, which gRPC version are you building again?" So the gRPC version I'm using is the one from Lorenzo's patch that you and him just released. This is probably because gRPC CRI API. So yeah, let's look and see. So to see which version of gRPC we're compiling in for the Falco gRPC server, we cat cmake modules gRPC.cmake and repository git. Where does it tell you the version? zlib protobuf. I don't see. There's a version. Let's do this. grep -I version. You are using use bundled on or not? I'm using use bundle equals off, Leo. You want to try it with on? Let's try it with on. See, do you see why I have this init shell script now? This is very convenient, right? Cool. So let's see. Use bundled on. Make Falco J4. Off means you're using the system gRPC. We're already at 90%, so this should go substantially faster since... Okay, so one of the things of cutting a release of NOVIX is I clean the system, right? I get rid of all of my precompiled objects, and I only leave like hand-picked ones left on the file system. So that's why it went substantially faster this time, because it was able to reuse a lot of the things that were already there. Leo says, if the system gRPC is GT125, the API implementation, the driver segfaults. So let's try this. Sudo user space falco -c etc falco.yaml falco. Let's see this. So far, so good. Let's not get excited. Let's run our container again and see what happens. Segmentation fault. And you know what we can do here is we can move init to temp. We can nuke all of this. Leo says damn, and then we'll move temp init back here, and we can just start a whole brand new build all over again. And then so this is my workflow. Then I have to go through and add all my changes to the dependencies and the lines of code and the libraries that I've been mutating, and get it working. And then I do a diff between this and what's in the Falco ARM branch, and that's my PR. Okay, so I will not bore folks much more with what we have going on here on this, other than I'm working on it. If you want to get involved, please download it and check it out. We would love to have you. And I'm going to spend the last few minutes here just showing you how you would set up Kubernetes on this, this NOVIX image moving forward. So Spencer says, pretty rad. So what we want to do here is we go to our home directory, and you have, if you cat Kubernetes readme, it's very simple. The first thing you do is you pick a host name, and then you do NOVIX k8s master. So you would do NOVIX host name. We're going to call it setns. We'll reconnect just to show you. And you can see now we're NOVIX at setns. And this sets host name in a few different places that we use. Max says it happens when a Docker container runs right. On my Raspberry Pi is so. Yeah, so far I've only been able to get that seg fault when a container runs, which is going to be a problem because, well, no, because I think we might be using CRI for this version of Kubernetes we have on here. So we can try it once we get Kubernetes up and running, and we'll see what happens. So anyway, our host name is setns, and if you look at this command, you can see it checks for your root, and then it uses hostname CTL, and then it also cats it to etc hostname, both of which are used by Kubernetes for one reason or another. I would say 90% of the problems people have with kubeadmin are from not having their hostname set correctly. If you've ever seen a node cannot be found, volume controller can't attach, can't connect to the server, unable to route, any of these classic kubelet error messages that are littered throughout the Kubernetes repositories, almost all of them are directly related to incorrect host names. So if you're not auditing and strictly managing your host names right now and you're trying to build Kubernetes from scratch, this is by far one of the things that I would encourage you to take into consideration first. So anyway, so we have host names there. And so now to set up Kubernetes, well, we're going to call k8s master, which is going to basically use this configuration file, which this is for Calico, and you would have to define a different subnet block if you were using Cilium or a different CNI provider, which I also feel like should be installed on the network or on the host and not through Kubernetes. So anyway, there's my commentary around allow privileged. Basically, if you want to install Kubernetes, you need to be privileged. It's a huge exploit. We should fix it. I'll get off my soapbox. Okay, so let's set up our master. NOVIX k8s master. Must be run as root. So again, the first thing it does is it echoes out your host name, and it'll error if they conflict. And then it just tells you this H is a variable we use, which is basically the home directory for both root and the user NOVIX on this file system. Leo says, have to go. Great work, kiddies. Making it build on ARM. Bye, Leo. Thanks for joining. And yeah, this is basically going to be using kubeadmin to get the master up and running. And let's look at the Falco logs. Let's get out of here. And let's NOVIX Falco logs. So Falco is stable as long as you don't run a container. So again, I think this goes back to that C group limit. I had it working with containers using a different, maybe that capital LPR needs to be adjusted. I was using a different value and it was not seg faulting in the past. So I might be updating that PR or opening up a new one here depending on what I find for this one. When I tested the PR that just got merged into the kernel driver repository, I tested that Falco ran and was stable, but I didn't actually run a container, which, yeah, it kind of makes sense. Anyway, Falco it's running, it's fine, it's stable right now. In fact, we're looking at the Falco logs. Nothing's happening on our host system. But it is kind of exciting to see Falco alert as kubeadmin does some pretty invasive things on our host behind the scenes. So it's kind of nice to get a glimpse into what's truly happening at the Linux level when we do set up Kubernetes. And having both of these kind of running at the same time. I haven't really seen anybody else do this and do this deep level of introspection, so it's exciting to see. So of course we're pulling the container images because I clean everything before I cut a release of NOVIX, so we're having to download the container image for the API server, for the controller manager, for etcd, for kubeproxy, for kubedns, etc., etc. The control plane is what one would call that. How we doing on time? We have 5 minutes before TGIK starts. So while we're waiting for this to bootstrap, Does anybody have any questions for me or anything they want to bring up, anything they want to share with folks before we wrap up our stream today? I'm going to cut over and see if there's anything here I want to call out. There's a ton of links here. Feel free to check these out if you're interested. And I think we've covered pretty much everything. Let's see who is in our chat here. So we have quite a few people. Please jump over to TGIK after this and tell Brian hi and send love from the security C and C++ folks over here at Sysdig. Max Geo says, error, file below etc open for writing. Oh yeah, so I think Max is probably doing the same thing I'm doing. How setns differs from setns syscall. I don't understand that comment, Omeg. But yeah, these are the Falco alerts for setting up Kubernetes. Error, file below etc open for writing. File below etc. I think a lot of these are. Oh, sorry, I forgot. File below /etc. open for writing. Let's see what we have here. File below /etc. File below /etc. These all look the same. I think these are. Oh, we got a seg fault. And I bet this is containers coming online. Let's look here. Spencer says, legit, the first time I said edit in etc, I was confused. Okay, so let's see what we have going on here. Oh, sure enough, we have containers running. Falco started seg faulting again. Let's, who thinks I can fix this seg fault in the next 4 minutes? Show of hands. If I get it, do I get to take the rest of the day off from work? Let's see. Falco build Emacs. You're on big face now, by the way. Thank you. Now I'm on. I can also do this if y'all want to see. If you want to see it teeny tiny in the corner, or I can go back here. We'll go here. Emacs sys source dupe lib sense user space lib sense C group limits.c++. Time is an illusion. Oh! Look what we have here. For some reason, my my patch to this code isn't here. I might have already fixed this. I might actually be able to fix this in 4 minutes. Buffer is read only? What? Oh, sudo. Sorry. Unsigned long. Okay, and now let's make Falco J4. Sudo. Let's see what happens here. Looks like it's downloading a lot of things. I'll keep this going. I don't want to cut over to TGIK, which starts in 2 minutes, so I don't want to compete there. But yeah, I'll keep this going if folks want to stick around and see if this will actually work. I have no idea how long this is going to take, though. It might be wise for me to just tweet about this afterwards, what ends up happening. And of course, you can try on your end as well. And if anybody finds anything, please feel free to go to the NOVIX repository. Where is that at? And well, the first thing you should do is you should all come in and start this repo, and then you should come in and you should open up an issue that talks about what it is that you discovered. So I'm going to do Falco segmentation fault with containers possibly related to C group limits. C setns for demo. Cool. So yeah, we're gonna go back to Big Face. Thanks for joining, everyone. I'll keep everybody updated on this image, the NOVIX project, Falco in general, what we're doing there. If you want to get involved, Wednesday mornings, 8 a.m. Pacific, every week, me and a lot of folks here, including Spencer, our friend from IBM, including Leo, our friend from Italy. Even sometimes I can convince Holden to join us as well. Captain Golo is sometimes there as well. AJ says thanks. Thank you all for joining. Happy Friday. Wash your hands. If you have somebody you can hug, give them a hug. I don't have anybody I can hug at my house. I'm all alone. Stay strong. Life's good. Keep hacking. Everything's going to be fine. Everything's going to be fine. So thanks for joining, everyone. And please let us know if you have questions. If you want to get involved, if you want to share a screenshot on Twitter, that would be great. We'll retweet it. If you want to share it with us, share it with Sysdig. It's going to be exciting as we start moving forward. So thanks again. And on that note, I'm out of here. It's Friday afternoon for me. I got all of the blinds in the house. I don't know if you can see behind me. I've got all the blinds closed. So I'm going to open up the blinds. I'm going to get some sun, and I'm going to start continuing to do what I was doing all week, but this time I'll call it fun instead of for work, and fire up that x86 server I have over on the couch there that's just staring at me this entire time, and get Arch Linux running on that, because of course I'm going to be running Arch Linux on everything, and get a server up online. And then we're going to have a handful of Raspberry Pis, NOVIX running on a giant server, NOVIX running on my Raspberry Pis. I mean, I'm just going to run NOVIX on everything, and I'm really taking this Linux distribution to the next step here. So yeah, hopefully this will keep me occupied throughout the weekend as I do my live streams, and I guess I created a fork of Linux. Even though I didn't change the kernel, does that count as a fork? Maybe it's a distro. Is that the right word for it? Whatever. I don't know. Anyway, I'm out. Thanks for joining, everyone. We'll see you next time.